This video contains audio content only. There are no visual elements or images accompanying the audio. If you're expecting to see video footage, please note that this is an intentional audio-only presentation. We recommend listening to this content rather than watching the screen. Thank you for your understanding and enjoy the audio. Welcome to a fascinating exploration of the Viverrid family. Join us as we uncover the secrets of these intriguing creatures, from their ancient origins and remarkable diversity to their crucial ecological roles and the conservation challenges they face. In easy-to-understand language, we'll delve into the world of civets, genets, and oyans, exploring their evolution, unique adaptations, complex communication, and the unfortunate connection to zoonotic diseases. Get ready to discover the hidden wonders of the Viverrid world and learn how we can help protect these remarkable animals for future generations. Our exploration into the secretive world of Viverrids doesn't start in today's dense rainforests or sweeping savannas. Instead, it begins over 50 million years ago, during the Eocene epoch, a world gradually cooling from a period of intense warmth. Imagine vast, lush forests stretching across continents, home to early primates just finding their foothold in evolutionary history. In this fertile environment, small, carnivorous mammals emerged, marking the humble beginnings of what would become the diverse Viverrid family we know today. These earliest Viverrids bore little resemblance to their modern descendants, today's sleek civets or agile genets. Fossils uncovered across Eurasia tell us they were small, no larger than a weasel or housecat, agile climbers adapted for life among branches and leaves. Their teeth revealed diets dominated by insects and small invertebrates, a sharp contrast to the varied diets, ranging from fruits to mollusks, of contemporary species. While their precise behaviors remain hidden in fossil shadows, we can glimpse their lives in the shape of their elongated muzzles and specialized teeth, early hints of the features that define modern Viverrids. As epochs passed, the Viverrid family underwent a remarkable diversification. Fossil remains scattered from Africa to Europe and Asia show how these animals branched out into an array of sizes, shapes, and dietary habits. Some lineages evolved larger, sturdier builds, while others remained small and nimble. Their diets diversified too, expanding from insect ivory to include fruits, vegetation, and even aquatic prey, enabling them to occupy numerous ecological niches. This evolutionary diversification gave rise to four distinct subfamilies we recognize today: Hemigolinae, Paradoxurinae, Genetinae, and Viverrinae, each marked by unique adaptations. The Hemigolinae emerged early, likely in the Oligocene epoch, evolving remarkable specializations for semi-aquatic or arboreal lifestyles. The otter civet, Cynegale benneti, for example, possesses specialized teeth robust enough to crush shells of mollusks and crustaceans, reflecting its aquatic diet. Palm civets within this subfamily display agile climbing abilities, reflecting their adaptation to forest canopies. Paradoxurinae appeared next, with species such as the binturong, Arcticus binturong, and various palm civets evolving during the Miocene epoch. These creatures adapted to arboreal life, relying heavily on fruit, their molars evolving rounded cusps perfectly suited for crushing and digesting fruit pulp rather than shearing flesh. This dietary shift highlights their adaptation to rainforest environments abundant with fruits. Later, during the Miocene, emerged the Genetinae, the genets and oyans, specialized for terrestrial life but retaining impressive climbing skills. Their slender bodies and sharp dentition reflect their carnivorous diets, comprising small mammals, birds, and insects. Genets adapted to diverse habitats, from dense forests to open savannas, showcasing the Viverrids' remarkable versatility. The Viverrinae, including the well-known African civet, Civetictis civetta, are the most recent subfamily, evolving primarily during the Pliocene and Pleistocene epochs. Typically larger and robust, they display broad dietary preferences, including small prey, fruits, and carrion. Their generalized diet reflects a flexibility allowing survival across changing landscapes and climates. One of the most fascinating evolutionary aspects of Viverrids is their specialized dentition. As these mammals diversified, their teeth adapted dramatically. Palm civets evolved teeth for grinding fruits. Genets retained sharper teeth suited for hunting prey. The otter civet developed crushing premolars for its aquatic diet. These differences reveal how dental adaptations played a crucial role in enabling vivarids to thrive in varying ecosystems. But teeth weren't the only evolutionary marvel. The skeletal structures of vivarids also reflect their adaptability. Their semi-retractile claws, distinct from fully retractable claws of cats, provided the perfect balance for both climbing and terrestrial locomotion. Such claws allowed vivarids to maintain traction on tree bark and ground alike, enhancing their versatility. Other skeletal features, elongated muzzles, specific positioning of cranial foramina, further distinguish vivarids from other feliform carnivores like cats and mongooses, marking them as a uniquely adapted lineage. Yet, vivarid evolution wasn't a straight line of success. Numerous species arose, flourished briefly, and vanished, leaving only fragmentary clues behind. Genera such as Semigeneta, Kichisha, Tugenictis, Canuites, and Siamictis represent extinct branches on this evolutionary tree, each possessing unique adaptations that illuminate the family's rich history. Semigeneta, for instance, a European Miocene vivarid, featured teeth suited for a diet heavier in meat compared to many of today's vivarids, highlighting evolutionary experiments that ultimately didn't survive changing climates and ecosystems. The path vivarids traveled, from tiny insect eaters of the Eocene forests to today's diverse, specialized creatures, is a powerful testament to evolution's creativity and adaptability. Over millions of years, they navigated drastic climate shifts, new continents, and changing food sources, adapting their bodies, diets, and behaviors to thrive. Through their fossilized bones, we glimpse ancient whispers of lives long past, piecing together a story still unfolding today. Indeed, the journey of the vivarids isn't over. Modern vivarids, scattered across Africa and Asia, continue to evolve and adapt to rapidly changing environments, human pressures, and ecological shifts. Their future, shaped by both natural processes and human impacts, remains uncertain but hopeful, a reminder of nature's enduring resilience. In tracing the vivarid's evolutionary tale, we gain a deeper appreciation for the complexities of natural selection, extinction, and survival. From Eocene shadows to today's vibrant diversity, their journey highlights the delicate interplay between adaptability and specialization, between survival and extinction. As we continue exploring the remarkable vivarid family, their ancient whispers remind us how deeply intertwined the story of one family can be with the broader narrative of life on Earth. Far from being a uniform group, vivarids today consist of more than 30 remarkable species spread across 14 distinct genera, each with unique adaptations to their varied habitats. Their forms and behaviors are as diverse as the forests, wetlands, and savannas they inhabit, creating a living tapestry of evolutionary creativity. Begin your journey in the lush rainforests of Southeast Asia, where you might glimpse the mysterious binturong, Arcticus binturong. Often mistaken for a bear due to its shaggy black fur and lumbering gait, this large, arboreal vivarid possesses an extraordinary prehensile tail, a rare adaptation among carnivorous mammals. This tail acts as a fifth limb, enabling the binturong to navigate the dense treetops with surprising dexterity. Astonishingly, its hind feet can rotate nearly 180 degrees, allowing it to descend trees headfirst with ease. An opportunistic omnivore, the binturong's diet includes fruits, leaves, insects, and small vertebrates, but figs are particularly favored. By dispersing seeds across its forest home, the binturong plays a crucial ecological role. Adding to its charm, the binturong emits a distinctive musky odor that closely resembles popcorn, an unexpected detail enhancing its mystique. Across the Indian Ocean, in the diverse landscapes of Africa, the slender genets, Genetis, thrive. These agile, spotted vivarids are nocturnal hunters, perfectly adapted to stealthy life in both dense forests and open savannas. The common genet, Geneta geneta, showcases remarkable adaptability, flourishing across habitats as varied as deep forests, dry savannas, and even urban areas. Its varied diet, rodents, birds, insects, and fruit, contributes greatly to its widespread success. In contrast, the Cape genet, Geneta tigrina, native to the forests of southern Africa, specializes in small mammals, its hunting prowess honed to target rodents in dense, wooded environments. Further north, the giant forest genet, Geneta victoriae, largest among its kin, prowls the dense forests of Central Africa, capturing larger prey such as small primates and birds, aided by its size and balance-enhancing tail. Each genet species, while sharing common ancestry, demonstrates a fascinating array of specializations, highlighting their evolutionary versatility. Returning eastward to Southeast Asia, the otter civet, Cynogale benneti, presents yet another striking adaptation. Perfectly suited to aquatic habitats, this elusive viverrid lives along rivers and wetlands, its webbed feet and dense, water-repellent fur enabling effortless swimming. With nostrils positioned high on its snout, it breathes easily while partially submerged. At night, sensitive whiskers guide it in hunting fish, frogs, and crustaceans. Rarely observed, the otter civet quietly fulfills a vital ecological role, contributing to the health and balance of its watery home. Another fascinating group within the viverrid family is the palm civets of genus Paradoxurus, renowned for their arboreal lifestyle. The common palm civet, Paradoxurus hermaphroditus, exceptionally adaptable, inhabits diverse settings from dense jungles to bustling urban areas. Its omnivorous diet encompasses fruits, insects, and small animals, and it famously consumes coffee beans that, after passing through its digestive system, produce the prized and controversial Kopi Luwak coffee. Within this genus, specialist species like the golden palm civet, Paradoxurus zealandensis, found exclusively in Sri Lanka's unique rainforest ecosystem, illustrate how isolation and habitat specialization shape evolutionary paths. Jordan's palm civet, Paradoxurus jordani, occupies a similar specialized niche in India's western Ghats, utilizing resources inaccessible to larger or more terrestrial viverrids. Yet the family's diversity extends beyond well-known species, encompassing a suite of less familiar but equally fascinating creatures. The banded palm civet, Hemigallus derbianus, inhabiting Southeast Asian forests, displays vivid black and white stripes ideal for camouflage. Its nocturnal behavior includes specialized hunting techniques, digging earthworms and insects from the forest floor with long, sharp claws. Austin's palm civet, Crotogale austoni, limited to the forests of Laos and Vietnam, faces severe threats from habitat loss and illegal hunting, becoming one of the family's most endangered members. Hose's civet, Diplogale hose, endemic to Borneo, remains among the rarest and least understood viverrids, with a secretive lifestyle challenging even dedicated researchers. In Africa, Linsang's poyanasp, resembling genets yet genetically distinct enough to warrant their own subfamily, Poyanina, occupy the canopy, specializing in arboreal hunting. Two recognized species, the West African oyan, Poyana laytoni, and the Central African oyan, Poyana richardsoni, rely on agility and stealth, hunting insects and small vertebrates under cover of darkness. Though similar in appearance to genets, these small predators represent yet another unique evolutionary branch within this richly diverse family. Together, the extraordinary viverrid family paints a vivid picture of evolutionary creativity, each species uniquely adapted to its particular role within complex ecosystems. Their remarkable physical traits, prehensile tails, webbed feet, specialized dentition, and diverse behaviors illustrate a powerful story of survival, adaptability, and resilience, reflecting millions of years of fine-tuned evolution. Yet this diversity is fragile. Human-driven threats, habitat destruction, hunting, and wildlife trade place many viverrid species at risk. Understanding the astonishing adaptations of civets, genets, and their relatives is not merely academic fascination. It's a vital step in ensuring their continued existence in an ever-changing world. As we delve further into their hidden lives, these animals reveal a rich tapestry of adaptations, behaviors, and ecological roles, each creature adding distinct color to the kaleidoscope that is the viverrid family. Their diversity reminds us of nature's endless capacity for innovation, reinforcing the importance of preserving these enigmatic animals and the habitats they depend upon. In the humid shadows of a Sumatran rainforest, under a canopy of tangled leaves and moonlit branches, a small-toothed palm civet, Arctigalidia trivirgata, silently descends through the treetops. It pauses briefly, sniffing the air, before swiftly rubbing its belly along a branch, leaving behind an invisible yet potent message, an intimate chemical whisper conveyed through scent. Among Viverrids, Civets, Genets, Oyans, and their kin, communication through scent is sophisticated and vital. Their bodies are natural perfumeries, equipped with specialized scent glands that produce a remarkable array of chemical signals. These glands vary considerably among species, positioned strategically across their bodies, each secreting a unique chemical signature. Most viverrids share one notable feature: the perianal glands, located near the base of the tail, releasing a musky secretion used in marking territory and conveying social information. Certain species, such as the banded palm civet, Hemigallus derbianus, possess additional abdominal glands, perfectly positioned for scent-marking branches during their characteristic belly-rubbing behavior. Other species, like the African civet, Civetictis civetta, rely on anal glands producing liquid secretions, leaving distinct olfactory footprints to communicate dominance, territory, or readiness to mate. But how do these simple marks transmit such detailed information? The secret lies in their chemical complexity. Viverrid scent glands produce an intricate mixture of compounds, an olfactory symphony blending various ketones, alcohols, and esters. One remarkable chemical, civetone, a macrocyclic ketone distinguished by its large ring-shaped molecular structure, plays a starring role in this chemical orchestra. Civetone is exceptionally potent and persistent, adding a uniquely enduring muskiness to civet scents. This longevity allows their scent marks to linger, continuing to speak silently long after the civet has moved on. Scientists use sophisticated methods, such as gas chromatography mass spectrometry, to unravel these scent mixtures. By separating and identifying each chemical component, they decode the nuanced language viverrids speak through scent. This invisible dialogue reveals astonishing details: a civet's sex, age, reproductive status, and even its hierarchical position within the community. In the Sumatran rainforest, another civet picks up the scent left behind by its predecessor. Pausing briefly, its whiskers twitch as it gathers vital information from the chemical message. Is this a competitor encroaching upon territory, or perhaps a potential mate signaling receptiveness? Depending on the context, this encounter might lead to aggressive marking behavior, a quiet withdrawal, or even a careful courtship dance, all silently orchestrated by these scented signals. These invisible chemical conversations are crucial to viverrid society, governing relationships, territorial boundaries, and reproduction. While scents intended for territory marking may persist over long distances, sometimes kilometers, others are brief, subtle, intended for intimate, close-range communication. Yet this natural olfactory artistry has historically captivated humans as well, leading to a complex, often troubling relationship between civets and humanity. For centuries, civetone-rich secretions harvested from viverrids, particularly the African civet, have been prized by perfumers as a luxurious and exotic ingredient. Civet secretion, valued for its ability to stabilize and deepen fragrances, became essential to many legendary perfumes, including Chanel No. 5 and Shalimar, adding a lingering, mysterious animal magnetism. However, behind the allure lay a troubling reality. Traditional methods of harvesting civet musk were frequently brutal. Civets were kept in cramped cages, their glands scraped repeatedly, often painfully, over months or even years. The demand, driven by luxury markets, resulted in widespread animal suffering and exploitation. Species targeted included not only the African civet but also the large Indian civet, Vivera zybetha, and the small Indian civet, Viverricula indica, though their musk was considered less desirable. Though modern perfumery has largely shifted towards synthetic civet substitutes, the natural product still retains a niche market among certain luxury brands. Advocates argue that natural civet musk offers a complexity and depth synthetic alternatives cannot replicate. This lingering demand perpetuates a small, controversial trade, primarily in Ethiopia and parts of Africa, where captive civets still endure harsh conditions. Organizations such as the World Society for the Protection of Animals, WSPA, and the International Fund for Animal Welfare, IFAW, advocate fiercely against these practices, pushing perfumers and consumers toward synthetic, cruelty-free alternatives. They strive to educate the public on the hidden costs behind natural civet musk, highlighting both the ethical concerns and environmental implications of the trade. Yet changing consumer preferences remains a significant challenge. Many perfume connoisseurs still hold the belief that natural ingredients surpass synthetic ones in quality and authenticity. Overcoming these perceptions requires persistent education and transparency, clearly communicating the realities of civet harvesting and promoting the benefits, ethical, environmental, and economic, of sustainable alternatives. The complex relationship between humans and civet musk is more than a story about perfume. It reveals deeper lessons about humanity's complicated relationship with nature, highlighting our ability and responsibility to choose compassion and sustainability over exploitation and cruelty. Back in the forests and savannas, Viverrids continue their intricate, invisible communications undisturbed by human affairs. Their natural scents quietly maintain social order, convey affection, establish dominance, and shape territorial boundaries. These animals are masters of a subtle language we only partially comprehend, yet one deeply intertwined with their evolutionary success. The hidden messages of Viverrid scent marking reveal the delicate, sophisticated ways in which these animals interact with their environment and each other. By carefully observing and decoding this invisible language, researchers gain insights that aid conservation, helping them better understand habitat requirements, social structures, and the impacts of environmental change on these elusive animals. The story of civets and scent is ultimately one of hidden connections, between animals and their ecosystems, between humans and nature, and between ethics and economics. As we learn to respect and appreciate Viverrids for their unique adaptations, including their extraordinary communication methods, we deepen our own understanding of nature's complexity, highlighting the importance of preserving the delicate balance upon which all life depends. In the silence of the rainforest night, the small-toothed palm civet moves quietly onward, its chemical messages whispering into darkness, leaving behind an invisible signature, a testament to nature's elegant and enduring complexity. Viverrids, with their secretive, nocturnal lifestyles, typically remain hidden from human view. Yet, increasingly, these elusive mammals find themselves caught between nature and human society, their lives intersecting ours in ways we've scarcely noticed, sometimes with devastating consequences. This intersection was dramatically illustrated in 2003 when the severe acute respiratory syndrome, SARS, virus emerged, casting an unwelcome spotlight on these animals and revealing their role as silent spreaders of zoonotic diseases. The SARS outbreak, originating in Guangdong province in southern China, drew global attention to the masked palm civet, Paguma larvata. Bats, natural reservoirs for many coronaviruses, transmitted the SARS coronavirus to civets, turning these mammals into accidental intermediaries. The civets, stressed and immunocompromised within crowded live animal markets, became ideal hosts, amplifying the virus and shedding large amounts in their respiratory secretions. Humans, in close contact with infected civets, unknowingly inhaled or handled contaminated material, becoming the next hosts in a devastating chain of transmission. Understanding this intermediate host dynamic is crucial. Intermediate hosts, such as the masked palm civet, allow pathogens to multiply, mutate, and adapt to new conditions before leaping to humans. Wet markets, where animals of different species are held together in close, stressful confinement, create ideal conditions for such viral leaps. Crowding weakens animals' immune systems, facilitating virus replication and increasing the likelihood of zoonotic spillover. SARS vividly illustrated the consequences of ignoring these conditions, infecting thousands, costing hundreds of lives, disrupting economies, and changing perceptions about human-animal interactions forever. Yet SARS was not an isolated incident. Viverrids have been implicated in numerous other zoonotic diseases, emphasizing the complexity of human-animal pathogen transmission. Consider Toxicura geneti, a parasitic roundworm found in Genets. The eggs of this parasite, shed through feces, contaminate soil and water, posing health risks to humans who accidentally ingest them. Once inside a human host, larvae can migrate through internal organs, causing visceral larva migrans, a serious condition leading to fever, cough, and abdominal pain. Severe cases can result in larvae invading the eyes, potentially causing blindness. Controlling infections demands public awareness, hygiene, and environmental sanitation. Another troubling parasite is Notadrus cauti, responsible for notodric mange, a contagious skin disease affecting cats and viverrids. Viverrids can harbor and spread these mites, inadvertently infecting domestic animals. Controlling outbreaks requires treatment of infected animals, thorough sanitation, and limiting contact between domestic pets and wildlife, illustrating yet again the interconnectedness of ecosystems. A more complex case is Armilifer maniliformis, a bizarre pentastome parasite with a life cycle involving snakes and mammals, including viverrids. Viverrids act as intermediate hosts, harboring larval cysts in their tissues. When snakes consume infected mammals, the parasite matures and produces eggs within the snake's respiratory tract, continuing the cycle. Humans can become accidental hosts by ingesting eggs, usually through contaminated water or improperly cooked wildlife meat, highlighting risks associated with wildlife consumption. Viverrids have also been identified as carriers of Leptospira interrogans, the bacterium causing leptospirosis, a serious disease characterized by fever, jaundice, kidney failure, and potentially death. Common genets, geneta, carry particular serovars, variants, of this bacterium, shedding them through urine. Humans become infected through exposure to contaminated water or soil, especially where genets and humans coexist closely. Although genets are not particularly efficient transmitters of Leptospira compared to rodents, their role emphasizes the necessity of maintaining hygiene, sanitation, and vigilance in communities living near wildlife habitats. To illustrate the realities vividly, imagine a scenario at a crowded wildlife market. A young boy accidentally cuts himself while butchering a masked palm civet. Unknown to him, the civet carries a novel virus, closely related to SARS. Initially dismissing symptoms as a cold, the boy soon falls seriously ill. Within days, others at the market fall sick, and an outbreak unfolds rapidly, overwhelming the local community. Though hypothetical, such a scenario highlights real vulnerabilities in human-wildlife interactions. Preventing future zoonotic outbreaks requires multifaceted approaches. Improving hygiene and sanitation in wildlife markets, restricting trade in high-risk species, and enforcing stricter health regulations can substantially reduce spillover risks. Increased surveillance and rapid diagnostic testing can detect emerging pathogens early, enabling quick intervention before local outbreaks escalate into global crises. Beyond viruses and parasites, viverrids also face threats from diseases transmitted by domestic animals. Canine distemper virus, CDV, carried by domestic dogs, can devastate wild carnivore populations, including endangered viverrids. Effective vaccination programs for domestic dogs in areas where they interact closely with wild carnivores are essential to protect wildlife from this deadly disease. Ultimately, the story of viverrids and zoonotic disease underscores our complex relationship with wildlife. As we expand further into natural habitats, increasing interactions between humans and wildlife amplify risks of disease emergence. SARS was a clear warning. Our actions have consequences, sometimes global and catastrophic. Viverrids, once unnoticed inhabitants of forests and savannas, have unintentionally become central to global health discussions. Yet they remain innocent bystanders in our encroachment on nature. Conserving their habitats, regulating wildlife trade, and promoting responsible interactions between humans and wildlife are not only ethical responsibilities, they are critical public health imperatives. Understanding viverrids' roles in disease ecology also offers invaluable opportunities for conservation and disease prevention. By studying their ecology, behavior, and pathogen-host dynamics, researchers gain critical insights into emerging infectious diseases, helping design strategies to protect both wildlife and human populations. These elusive creatures, adapted for quiet survival, have inadvertently illuminated vital lessons about our shared vulnerability with wildlife. Their silent role as disease carriers does not condemn them, but rather compels us toward thoughtful coexistence, acknowledging the interconnectedness of human, animal, and environmental health. In the shadows of forests and urban fringes alike, viverrids continue their secretive lives, unaware of their complex relationship with human health. Their story calls us to recognize the delicate balance we must maintain between respecting nature's boundaries and fulfilling our own needs. Protecting viverrids, their habitats, and the ecosystems they represent ultimately safeguards our own future. one where humans and wildlife coexist safely, healthily, and sustainably. As night falls, the Viverrids awaken, silently moving through the darkness. Their presence is a subtle reminder that the invisible lines separating us from wildlife are thinner than we imagine. How we choose to navigate these lines, respectfully or recklessly, will shape not only their future but also ours. As darkness falls over the forests and savannas of Africa and Asia, Viverrids quietly awaken. These secretive mammals, civets, genets, binturongs, and their kin, serve vital roles in their ecosystems, yet their survival hangs by a thread. Across their range, habitat destruction, hunting, and wildlife trade are driving many species toward extinction. Habitat loss remains the most pressing threat. Take, for instance, the Malabar civet, Viverra civetina, critically endangered and confined to fragmented forests in India's western Ghats. Once widespread, the Malabar civet now survives only in isolated pockets, struggling to withstand rapid deforestation, agriculture expansion, and urbanization. Roads further fragment these fragile habitats, isolating populations and weakening their chances for survival. Similarly, Southeast Asia's small-toothed palm civet, Arctigalidia trivirgata, sees its rainforest habitat shrinking as forests give way to palm oil plantations, agriculture, and logging. Even adaptable species like the common genet, Geneta geneta, which tolerates human-altered landscapes, face population declines as their natural habitats steadily disappear. Specialist Viverrids face even greater risks. The otter civet, Cynegale beneti, dependent on wetlands, rivers, and peat swamps, is severely threatened as wetlands are drained, polluted, and transformed into agricultural land. Pollution from agricultural runoff and industrial waste further compromises their delicate habitats. Likewise, Africa's aquatic genet, Geneta piscivora, faces similar dangers as rivers and marshes suffer from degradation and human disturbance. Poaching for meat, traditional medicine, and fur poses additional threats. Austin's palm civet, Crotigale austoni, restricted to Vietnam and Laos, has declined drastically due to hunting. Snaring, common across Asia's forests, indiscriminately kills wildlife, placing Austin's civet among the world's most endangered mammals. Hunting driven by cultural beliefs and economic necessity presents a significant conservation challenge, as communities often depend on wildlife products for food and income. Illegal wildlife trade adds another troubling dimension. Charismatic species like the binturong, Arcticus binturong, are captured from the wild for the exotic pet market, frequently enduring inhumane treatment during transport and captivity. The illegal trade not only devastates wild populations but also risks introducing zoonotic diseases as humans closely interact with wild animals, creating pathways for new viruses to emerge. Historically, Viverrids faced intense persecution due to the perfume industry's demand for civet musk. The African civet, Civetictus civeta, was heavily exploited for its secretion, harvested under cruel conditions from captive animals. Although synthetic alternatives now largely dominate, natural civet musk remains in limited use, fueling ethical concerns and perpetuating animal welfare issues. Yet, despite these daunting threats, the situation is not without hope. Conservation efforts worldwide strive to protect Viverrids and their habitats. Creating and enforcing protected areas provides essential sanctuaries, enabling populations to recover away from human interference. Habitat restoration projects, such as reforesting corridors in the Western Ghats, reconnect fragmented landscapes, enabling isolated populations to mingle, maintain genetic diversity, and increase their chances of survival. Organizations such as the Wildlife Conservation Society, WCS, World Wildlife Fund, WWF, and the IUCN Small Carnivore Specialist Group spearhead vital initiatives, raising awareness and conducting targeted conservation projects. Equally important is community involvement. When local communities recognize economic and ecological benefits of conservation, they often become powerful allies. Initiatives like ecotourism, when managed responsibly, offer sustainable income while promoting conservation and educating visitors about these remarkable animals. The ecological role of Viverrids underscores their importance. Binturongs, for example, disperse fig seeds throughout their rainforest homes, ensuring the continued growth and diversity of essential plant species. As predators, genets help regulate rodent populations, preventing crop damage and reducing risks of disease transmission to humans. Losing viverrids could trigger cascading ecological consequences, disrupting entire ecosystems. The future of viverrids ultimately depends on us. Recognizing their ecological value, addressing habitat loss, controlling wildlife trade, and supporting conservation efforts are vital steps to ensure their survival. By protecting these nocturnal guardians, we preserve not just fascinating animals but the intricate ecosystems they help maintain. In quiet forests under the cover of night, viverrids continue their crucial work, silently shaping the natural world. Their fate is tied directly to ours, a powerful reminder of the interdependence connecting all life. By safeguarding viverrids, we protect the delicate balance essential for our shared future, ensuring these guardians of the night continue thriving under moonlit skies. Viverrids, a diverse family of carnivorous mammals, have evolved over 50 million years, adapting to a wide range of ecological niches. Their diverse scent glands, critical for communication, have also been exploited by humans for perfume production, raising ethical concerns. Viverrids are implicated in zoonotic disease transmission, highlighting the interconnectedness of human and animal health. Habitat loss, poaching, and the illegal wildlife trade threaten many species, but conservation efforts offer hope. The future of these fascinating creatures depends on our understanding and actions. What are your thoughts on viverrid conservation? Share your questions and ideas in the comments below. Subscribe for more wildlife explorations, and let's continue learning together.